I have to go to this.
Tyler, welcome to the pre-class video. We're starting a new chapter.
Oh, that's exciting.
It is. Equilibrium. Equilibrium. And we're going to start off by tying this into some ideas that we learned about in kinetics.
Okay.
Right? In kinetics, we learned about what happens to the concentration of reactants and products over time. Right? And we start looking at these graphs, concentration on one axis and time on this axis. And if I look at the concentration of the reactant, say we start off with a concentration of A at around there.
Sure.
Okay? Well, what happens to the reactant as time goes on?
Well, you're going to lose reactant as it gets converted to product. So the concentration is going to go down.
It goes down, and usually it's going to go down in kind of a curve like that. Right? And it goes until the reactant is used up. Well, what's the product curve going to look like?
Well, as you're converting reactant to product, your products are going to start at 0 and then start climbing up.
Okay, and they're going to start climbing up, and since it's a ratio of 1 to 2, the amount when we use up one of these, we're going to produce 2 of those,
right.
And so we're going to get actually a twice as steep curve and twice as high curve, right? So the B is going to start going up, but it's going to end up twice as high as the A started.
Right, because for every time one A gets turned into product, you get 2 Bs.
Yep.
So.
But bottom line is this B concentration, I didn't draw it very well, is going to end up being flat.
Right, as is your A concentration.
As is your A. You stop using it.
Flat at 0.
Right. Okay. Well, this is a typical reaction where you convert completely to products, and that's called a quantitative reaction. You quantitatively convert from reactants to products. But it turns out there are lots of reactions that don't do that. There are lots of reactions that go part way. Come on with me. We'll look at this. Okay, so here we have exactly the same graph to start off with, but I'm just saying reactant is C and a product is D. Some other reaction.
Right.
Same ratio. Not the one we were looking at. Well, what's C going to look like? Well, C is still going to start off at a concentration that's high. Let's say it starts off there.
Sure.
And as the reaction goes, it's still going to drop off. But sometimes it doesn't go all the way down to the bottom. It doesn't go all the way to 0. It just kind of stops.
Right, we see it go flat again, but it's not flat at 0 like A was.
Yeah. And then for D, D will increase, and it will increase by about twice as much as this decreased. So it's going to look kind of like this.
There you go.
Okay. So again, it flattens out. And the C curve flattens out pretty much at the same time as the D curve flattens out, but they might be at different levels.
Right.
So in our final mixture, we have some C and some D.
Mm-hmm.
Okay? Well, why does that happen? Well, it happens because in a lot of reactions, they don't just go forward, they go backwards as well. And that's because the activation barrier going forwards and going backwards are about the same. And so molecules can go over, but once they're there, they can come back as well.
Right, so there's kind of an exchange, right?
Exactly, kind of an exchange. And you end up with a mixture of reactants and products. In fact, it becomes a little bit ambiguous sometimes what's a reactant and what's a product. Right? It's really, for these reactions, defined by, at the start of the problem, or by what you kind of put in. And what determines kind of where these play out in terms of concentration is that it turns out it's when the rate of the forward reaction equals the rate of the backward reaction. Right? You're making product, you start to make, the product starts to come back as reactant, and so both reactions are going at the same time, and when they balance out, you make as much product as you use up.
Right, so then it ends up just not changing the concentration of either.
Exactly, exactly. And that's called equilibrium. It's balanced.
Oh, it's our topic.
Yeah.
Okay.
Okay. So hopefully this is enough to get us started, and we'll see you in class.